Oops. All right, so we're going to do a specific heat example. I think I'll use aluminum at first. And so remember, here's the equation Q equals mc delta T. Let's take a closer look at that. Okay, so Q equals mc delta T. That means, of course, the mass times this C, which is the specific heat, times the change in temperature, the final temperature, minus the initial temperature. Q is heat. It's measured in calories. The mass is in grams of the substance. It could be a liquid, it could be a solid, it could be a gas. The specific heat is measured in units called calories per gram degree Celsius. So the calories is on top and the gram times degree Celsius is on the bottom. It's a little strange what the units are there, but that's the way it works. And the temperature is always in degrees Celsius. So let's start with some mass of aluminum. So I'll put Al, mass of aluminum. And let's say we had, I don't know, how about 200 grams of aluminum. All right, so that's supposed to be a G. That doesn't look like a G, sorry. So that's 200 grams of aluminum. All right, so now the specific heat of aluminum, and it's different for all substances. It would be different if the, hold on. All right, and as we saw for aluminum, the specific heat of Al is 0.22, and the way the units look is this, of course, calories divided by grams and degrees Celsius. All right, the degree Celsius goes in the denominator. All right, that doesn't look very nice. Sorry. All right, and that's grams. Okay, let me point one thing out right here. This specific heat. I know this is important for your homework. If I wrote this as kilocalories per kilogram degree Celsius, so let me just do that real quick. So the specific heat for aluminum is 0.22, and if it was kilocalories, remember those are the food calories per kilogram degree Celsius. And your book writes it this way several times, and I just want to point out numerically. This is the specific heat for solid aluminum. This number and this number are identical, and the reason for that is the K's just cancel. Okay, so the normal way that we will use it is calories per gram degree Celsius. Okay, so let's go ahead and do this. So we want to know, for example, so I didn't really set up the problem very well yet. So let's say we had this aluminum going from, 20 degrees Celsius is our initial temperature, and our final temperature is, let's say, 100 degrees Celsius. And we want to know what Q is. How much energy did we pour into raising the temperature of this 200 grams of aluminum? So the initial temperature is 20 degrees Celsius, and the final temperature is 100 degrees Celsius. We often use 100 because you're just taking, let's say this is about room temperature aluminum and putting it into boiling water, for example. That's a good experiment that's done quite often. All right, and so let's put all the numbers in, and so Q, our amount of heat in calories, is going to equal, so it's 200 grams times the specific heat, which we know to be 0.22, and of course that's calories per gram degree Celsius. And the change in temperature, so it's going to be T final 100 degrees Celsius minus 20, the initial 20 degrees Celsius. Okay? And that'll give us the amount of energy in calories. So this is going to be some number of calories with a small, that's supposed to be an L. Alright, so let's do this calculation. Alright, so when I do this calculation, it's basically 80 times 0.22 times 200. I get the amount of heat required to raise 200 grams, through an 80-degree change in temperature, 3,520 calories. Calories. And I want to do one more step, because you'll do this as homework as well in the book, and just remind you of what's called the joule equivalent of heat. Oops, sorry, wrong thing. Right here, there we go. And here is this thing called the joule equivalent of heat, that 1 calorie, so these are the calories that we usually use, or sometimes it's called the mechanical equivalent of heat. 1 calorie is 4.184 joules. So what we can do now is go back to this, and we can convert this into joules instead of calories of heat. So we know that 1 calorie, so notice I'm putting this in the denominator, right, because we want to cancel calories, is 4.184 joules. And so now this is now going to be, instead of heat in calories, it'll be heat in joules, which is, the same units of energy that we were talking about in chapter 3. So let's do this calculation. Alright, and so I just used my calculator, and I'm going to write the answer. So it's 14,000. And hopefully you're doing these problems as I'm doing them as well, or just afterwards, that's fine. So you make sure you get the same numbers. 14,727 I'm going to just call it 0.7. Okay, and that of course is joules. Joules of energy, just like the mechanical energy that we've been talking about. So there's an example, and let's see. I'm going to set up another example. This time we're going to use water and liquid water. So the specific heat of liquid water, I'll just say W here for water. And there's of course 3 phases of water that we're interested in: water as ice, water as liquid, and water as steam. But the specific heat for water as a liquid turns out to be 1 calorie per gram degree Celsius. That's the one that I don't ever have to look up. And let's say, well, here, I'm going to continue this on the next screen. Alright, so this is our starting point. We know that the specific heat of liquid water is 1 calorie per gram degree Celsius. Let's say, for our example, with liquid water, we have a mass of water of 1 kilogram. Okay, and we know that let's say that the amount of heat added to the water, let's say, or actually let's do this, let's take the heat away. So we'll make it negative. Okay, so this is going to be negative, let's say 25,000 calories. So we remove that much heat, and let's say our initial temperature, T initial, is 50 degrees. So it's not, it's halfway to the boiling point on the Celsius scale. Whoops. So that should be a C. Alright, so 50 degrees is our initial temperature, and the question is, what's the final temperature? So if we remove, so the final temperature is what? If we remove 25,000 calories from 1 kilogram of water, of liquid water, initially at 50 degrees Celsius, what's the final temperature? Okay, so that's a question that we can answer with our specific heat equation. And so let's set it up. So we know Q, we know M, we know C, and the thing that we don't know is the final temperature. So we're going to find T final, but of course we know T initial. All right, so to do this, what do we have to do? We have to solve for T final over here. And since these are being subtracted, what I'm going to do is just divide both sides by MC. Okay, so it's just a little algebra. So divide both sides by MC. And these, this M cancels this M, this C cancels this C. And then you're going to have T final. Here, I'll write it right down here. So you'll have T final minus T initial will equal Q over MC. Okay, so this is just algebra. This is just in general. And then to solve this, since we were trying to solve for T final, what I'm going to do is add T initial to one side, and then add T initial to the other side. The reason that we do that is, of course, if you had positive T initial and minus T initial, the T initials go away on the left-hand side in this case. And so T final, the final temperature, is going to be Q over MC. And in this case, since we added T initial to both sides, so this is plus T initial. All right, and everything, notice on the right-hand side, we know, we have the values for all that, and we just have to put them in. So let's see, it was negative 25,000, right, is the temperature. All right, so this is negative 25,000 calories. And that's divided by, now here's the thing about this, notice I didn't do this yet, but the conversion, this has to be in grams, so I'm just going to replace K by what it is, so that's of course 1,000 grams. Alright, so I'm going to use that down here, so this is 1,000 grams, and this of course is just 1 calorie per gram degree Celsius. And notice the grams are canceling, the degrees, the calories are canceling, and then we're going to have plus our T initial, plus T initial, which our initial temperature, I believe, was 50 degrees Celsius. Oops, that's supposed to be a degrees Celsius. All right, so we can put this in our calculator. I mean, you can almost see the answer, but let's, just to be make sure that we're correct, we'll put all this in our calculator. So this becomes negative. This part right here is negative 25. So this is basically going to be negative 25, and it's going to be this degrees Celsius goes up to the numerator, and that's plus 25. I'm sorry, plus 50. Sorry, that's wrong. Plus 50 degrees Celsius. I was getting a little ahead of myself. And so positive 50 and minus 25, of course, gives us a final temperature. I'm forgetting what I'm solving for. A final temperature of positive 25 degrees Celsius. Positive 25 degrees Celsius. And so what we've done, let's just review this real quickly. We've removed 25,000 calories from 1,000 grams of water, and which had an initial temperature of 50 degrees Celsius, and so removing that amount of heat gives us a final temperature. Whoops, right here. Our final temperature of 25 degrees Celsius.